For most of human history, the ground beneath our feet was the ultimate definition of permanence. Mountains rose, rivers carved valleys, but the continents themselves were fixed. Africa had always been exactly where it is. Look at the coastlines of South America and Africa. They fit together like pieces torn from the same sheet of paper. To early geologists, this was a geographic fluke. Massive land masses do not slide around the globe, and the scientific community dismissed the alignment as a mere coincidence. We naturally assume the Earth's surface is stable. Our lives are too brief to perceive rock and soil drifting across the planet at the speed human fingernails grow. In 1912, a meteorologist named Alfred Wegener started searching for physical matches across the Atlantic. He spread geological surveys across his desk and began comparing opposite sides of the ocean. The similarities multiplied. Entire rock formations in Brazil matched formations in West Africa, layer by precise layer. Ancient mountain chains cut off by the ocean seemed to pick right back up on the other side. Then he looked at the fossil record. This is Mesosaurus, a freshwater reptile from 280 million years ago, found in both South America and Southern Africa. That posed a major problem. A small lizard could not survive a swim across thousands of kilometers of ocean. The climate data was even stranger. Wegener found deep grooves carved by ancient glaciers in the middle of tropical Africa and fossilized plant species that require warm weather buried under the ice of Antarctica. Individually, these anomalies were bizarre. Together, they pointed to a single massive landmass, a supercontinent Wegener called Pangaea, that slowly broke apart over millions of years. The rocks, the fossils, and the glacial scars all suggested a moving Earth, threatening to shatter the established scientific paradigm. But there was one massive problem. Wegener could not explain how a continent actually moves. Land masses weigh trillions of tons. To move across the globe, they would have to plow straight through the rigid rock of the ocean floor. The physical forces required to do that simply did not exist. Geologists demanded a mechanism. Wegener tried to point to Earth's rotation or tidal forces, but the math failed. Without a way to explain the physics, the scientific community rejected the idea entirely. Wegener died in Greenland during a brutally cold expedition in 1930. For decades, his theory was largely written off as an elegant but impossible fantasy. You can have mountains of observational data, but if you cannot prove the mechanics of how it happens, a theory stalls. The geological records on the surface were clear, but the engine driving them remained out of reach. The engine finally revealed itself during World War II. Naval vessels equipped with new, highly sensitive sonar technology began mapping the depths to detect submarines. Researchers expected to find a flat, featureless plain. Instead, they discovered massive, 16,000-kilometer-long mountain ranges wrapping around the planet underwater, along with deep valleys and high volcanic heat. As molten rock rises from these ridges and cools, microscopic magnetic minerals inside it align with Earth's magnetic field, acting like tiny compass needles frozen in stone. Survey ships found alternating magnetic stripes. One matched our current field, the next reversed, mirroring perfectly across the central ridge. Center rocks were young, while outer bands reached 150 million years. New crust continuously formed, pushing older rock outward. The ocean floor itself was spreading. The continents weren't breaking physical laws by plowing through rigid crust. They were passively riding on top of massive moving tectonic plates, floating over the hot mantle below. Today, we don't have to rely entirely on ancient rocks to prove this. Modern GPS satellites track this motion down to the millimeter. North America and Europe drift apart by about 2.5 centimeters every single year. But a planet covered in shifting plates is an inherently violent place. Along the boundaries where these masses collide and grind together, friction causes them to lock up. Over decades or centuries, immense physical pressure builds in silence. When that rock finally snaps, the sudden release of energy shoots upward. During the 2004 Indian Ocean earthquake, parts of the seafloor shifted by more than 15 meters in seconds. The resulting tsunami released energy equivalent to hundreds of millions of tons of TNT, killing over 200,000 people. Mountains, ocean trenches, island chains, and earthquakes are all connected. They are the visible exhaust of a massive geological engine operating deep underground. When we look at a map, we see rigid borders and permanent landmasses, but that stability is an illusion created by our short perception of time. Entire human civilizations rise and fall in the time it takes the Pacific Plate to move a few meters. Hundreds of millions of years from now, long after the cities we have built are gone, the rock beneath us will keep drifting until it merges into another supercontinent. Wegener never lived to see his theory proven, but the planet kept moving, continuously recording its own history in the ocean floor, leaving undeniable evidence.